Okay, today is going to be a review over all of Chapter 10. That's a lot of material, so obviously it's going to be brief on each section, but we're going to hit on everything that you should know for the test. Okay, so we're going to start where Chapter 10 starts, and that's just finding square roots. Alright, so here's 4 square roots that I want you to find. Okay, I'll give you a second and then we'll talk about them. Alright, now on these, you either hopefully recognize the perfect squares, or if you don't, on these you can use your calculator. Okay, so you should recognize that 169 is just 13 squared, so the square root of 169 is 13. Okay, for the negative square root of 25, okay, well 25 is a perfect square. 5 squared is 25, so the square root of 25 is 5. But since there was a negative in front of the radical, we put a negative in front of our answer. So our answer here is negative 5. Alright, for number 3, same idea. The square root of 1 is 1, but we have this symbol, plus or minus, which means it wants both answers. So it's going to be plus or minus 1. Okay, now you could also write that as two things. You could write 1 comma negative 1, or you could just use this symbol, plus or minus 1. Alright, and number 4. Okay, 49 is a perfect square. 7 squared is 49, right? But this doesn't say 49. It says negative 49. I can't square anything and get negative 49. That's why the answer to this is no real number. Okay, there's no answer to this one that's a real number because the negative is on the inside of the radical. Up here, the negative is in front of the radical. That's fine. It just makes your answer negative. But if the negative is inside the radical, then you have to write no real number. Alright, the next thing we have to do is estimate square roots. Now these are the ones that you will not be allowed to use your calculator for. So you have to show your work and how you came up with your approximation. Okay, so we have 2 square roots and we are trying to approximate or estimate each of them. Alright, so for the square root of 15, remember, the first thing you do is look for perfect squares around 15. You need one that's a little less than 15, one that's a little more than 15. Well, I know that 9 is a perfect square, and so is 16. So the square root of 15 would have to be in between the square root of 9 and the square root of 16. Well, the square root of 9 is 3, and the square root of 16 is 4. So I know that this has to be in between 3 and 4. Well, 15 is a lot closer to 16 than it is 9, so I'm going to pick a number that's closer to 4 than it is 3, so 3.8. And that's my approximation or estimation for the square root of 15 without a calculator. I must see this work or it will be marked wrong. Okay. Alright, for number 2. Again, I'm looking for perfect squares around 52 this time. Okay, so I use 49 and 64. Now notice, since this one was negative square root, I just made these negative square root and negative square root. Doesn't really change what I'm doing. Alright, and the negative square root of 49 is negative 7. The negative square root of 64 is negative 8. So I know I'm in between negative 7 and negative 8. Well, 52 is a lot closer to 49 than it is 64, so I'm going to pick a number a lot closer to negative 7 So I do negative 7.2. And there's my estimation for the negative square root of 52. Okay, so the key to estimating square roots is knowing your perfect squares. If you don't know your perfect squares, then you're not going to be able to estimate this without a calculator. And that's what you're going to have to do for the test. Alright, now for this one you're going to have to identify the numbers as either rational or irrational. Now don't forget, you should also be able to tell if it's a whole number or an integer as well. But you learned those a long time ago, so we're just going to talk about rational and irrational this time. Alright, so you have 4 numbers. You need to write down whether they're rational or irrational. Alright, so number 1 is the square root of 25. Well, it has a radical, so you might think, well, maybe it's irrational. Except the square root of 25 is just 5. So really, we're just looking at the number 5. And the number 5 is a rational number. Okay? It's also, by the way, a whole number and an integer. Alright, so now looking at number 2. Number 2 is 6/11, or 6 over 11. Well, that's a fraction. And any number that can be written as a fraction is rational. So that one's straightforward, because it's already written as a fraction, so I know it's rational. Alright, now number 3. Oh, I see another radical. Okay, and inside the radical this time is not a perfect square. That means automatically that that's an irrational number. Okay, notice the difference here. Both of these are square roots, but this square root is a perfect square. This one is not. That's why this one was rational and this one is irrational. Alright, now looking at number 4. Okay, it's a decimal that repeats. Well, that's rational. Okay, remember, if the decimal stops or repeats, then it's a rational number. Okay, but just to make sure, we can turn this into a fraction. If you remember decimals to fractions, that's just 4 and 5/9, because since the 5 is repeating, you have to take 1 off of the decimal. So yes, I can definitely write that as a fraction, so it is a rational number. Okay, and that's how we tell if a number is rational or irrational. Alright, also with rational and irrational numbers, we have to be able to tell which number is greater, which one's bigger. Okay, so I've got 2 problems here, and you need to figure out whether you need a less than sign between them or greater than sign between them. Alright, so when we do something like this, remember, we can't really compare decimals with square roots. So we're going to have to convert everything to decimals. So we even have fractions down here. We got fractions, decimals, square roots. Okay, so we got to make everything a decimal. Okay, so I'm going to change my square root here to a decimal. Okay, so now I have 6.25 repeating and 6.2449, and it keeps going on forever because it's irrational. Now it's easy to see which one's bigger, because this one is 0.25, that one's 0.24, so this is the bigger number. 6.25 is greater than the square root of 39. Alright, same thing with number 2. I need to write them both as decimals so that I can compare. Well, this is just negative 11.1 repeated. Okay, you could just put in your calculator, 1 divided by 9 is 0.1 repeating. Alright, and then I can put this in my calculator. I don't have to worry about the negative because I know the answer is going to be negative. I can just type in square root of 124 and I get 11.1355 dot dot dot. It keeps going forever. So now I can compare these two decimals. Well, 11.11 and 11.13. Well, this one's a bigger number, right? Except these are negative. Okay, so if a number is more negative, that actually makes it less than the other number. Okay, so negative 11.11 is greater than negative 11.13 because it's a smaller negative number. So therefore, negative 11 1/9 is greater than negative square root of 124. Alright, and we also have to solve equations with squares in them. Okay? So, see if you can solve each of these three equations. Alright, for number 1, well, the square is already by itself, d squared, so all I have to do is one step, and that's square root both sides. So when I square root d squared, I get d, and when I square root 100, I get plus or minus 10. Because remember, if I square positive 10, I get 100, but also if I square negative 10, I get 100. So either one is the answer. Both of them are the answer. So you have to have both. Alright, now number 2 is a little more complex because the square isn't by itself. But that's okay because we know how to get it by itself. There's a times 4, so to get rid of that times 4, I have to divide by 4. Okay, so I have y squared equals 9. Well, now that looks more like number 1. I've got the square by itself, so I can square root both sides. And I get y equals plus or minus 3. Because if I put a positive 3 or a negative 3 in for this y, then this will equal 36. So both of these have two answers. Positive 10 and negative 10, and positive 3 and negative 3. Alright, now number 3. This time I have a decimal. Well, that doesn't really change anything. I do it the same way I did number 1. I take the square root of both sides. So the square root of n squared is n. Now the only thing different here is I'm going to use my calculator. I knew the square root of 100, but I need my calculator to do the square root of 5.76. So I'm just going to type it in. And the square root is 2.4. And I didn't forget that it's positive or negative 2.4. So that's my solution. So sometimes you may need your calculator, sometimes you may not. Either way, you can still solve the problem. Alright, now we're getting into triangles. Okay, you need to find the value of x and then classify each triangle based on its angles and based on its sides. Okay, so you should find x and then give both classifications for the triangle. Okay, so you got two triangles here. This one has a 60 degree and a 25 degree, and then an X. This one has 63 degrees, 63 degrees, and a 2X. So you need to find X, and then you need to classify the triangle. Alright, so for the first one, I know that X plus 60 plus 25 equals 180, because all triangles add up to 180 degrees with the interior angles. Alright, so then I have x plus 85 equals 180. So then I have to isolate the x, so I can move the 85 over by subtracting 85. And that gives me x equals 95. So I found x. X is 95. Well, now I have to classify. Well, 60 is an acute angle, 25 is an acute angle, and 95 is an obtuse angle because it's bigger than 90. So this is an obtuse triangle because it has an obtuse angle in it. Alright, and I can't really tell if any of these sides are the same, but I know none of the angles are the same, and that tells me that none of the sides are the same. So if none of the sides are the same, then that also makes this a scalene triangle. So this is an obtuse scalene triangle. Alright, and for the next one, this time instead of an x, I have a 2x. Okay, so I have 2x plus 63 plus 63 still equals 180 because all triangles equal 180. So 2x plus 126 equals 180. So now I have to move the 126. I can subtract it. That leaves me 54. And I need to divide by 2 to get rid of the 2. And that gives me that x equals 27. Okay, so I know that the x is 27. Now the angle is 2x, so that would be 54. So you can see that 54 plus 63 does equal 180. Okay, but the x is 27. Alright, now to classify. Well, first I see that two of the angles are the same, and I notice that there's some congruence marks. So I know there's two sides that are the same. Well, that makes it an acute isosceles triangle. Okay, because all three angles are acute. That one's 54, this one's 63, 63. So all three angles acute makes it an acute triangle. And having two sides and two angles congruent makes it an isosceles triangle. Alright, next we're going to be finding missing links of a triangle. More specifically, missing links of right triangles. Because if they're not right triangles, we don't know how to find the other sides. Okay, so here's two triangles. Notice they're both right triangles. This one side is 20 centimeters, one side is 7 centimeters, and you need to find how long the other side is. Then on the other one side is 40 inches, another side is 50 inches, and you need to find the third side. So, I'm going to give you a second to work on that, and then we're going to go over them together. Alright, now, first you're looking for x. The first thing you should know, or notice, is which side you're missing. Well, it's across from the right angle, which means it's the hypotenuse. That means that this is your C value. Okay, A and B are the two legs, C is the hypotenuse. So we can use Pythagorean theorem to find how long this side is. Okay, so A squared plus B squared equals C squared. So I did 7 squared plus 20 squared equals x squared. Alright, so that's 49 plus 400 equals x squared. So 449 equals x squared. So I got to take the square root to get rid of the square, just like we did earlier, a couple slides ago actually. And I get that x equals 21.2. Okay, and I just put that in my calculator. Now, maybe I could have approximated it if I knew my perfect squares that high, but I don't even have to worry about that. I just type this in my calculator, round to the nearest tenth, and I have 21.2. Okay, so this side is 21.2 centimeters long. Alright, now, for the second triangle, I'm missing this side over here, the y. Well, the right angle is here, so that means this side is my hypotenuse. The hypotenuse is 50. I already know that. That's C. Okay, so I'm not missing C this time. This time, I'm missing A. Or B, doesn't really matter if I call it A or B, but I'll call it A. Okay, so this time I know B, I know C, and I'm missing A. So when I fill out my formula, A squared, which is y squared, plus B squared, which is 40 squared, equals C squared, which is 50 squared. Okay, so I've got y squared equals 1600, y squared plus 1600 equals 2500. So I need to move the 1600 to the other side because I got to get the y squared by itself. So I subtract 1600 and I get y squared equals 900. Well, now that I have the square by itself, I can square root both sides and I get y equals 30. Okay, so the length of this side is 30 inches. Now, just a note back a couple slides ago, when we solved these problems before, I had to do plus or minus 30 because I could square 30 or negative 30 and get 900. Okay, but here we're talking about distance. How long is this side? So the negative answer doesn't really make sense because you're not going to have something that's negative 30 inches long. Okay? That's just, negative is just a direction, just means 30 in a different direction. So when you're talking about length, then everything's positive. That's why I only need the positive answer for my Pythagorean theorem, whereas when I'm just solving an equation, I need all solutions. Okay, so that's why we don't need both solutions for these problems. Alright, and that's also why we don't need both solutions for the distance problems as well. Alright, which is what we're going to be doing now. So you're going to find the distance between the 2 points. Alright, so for the first one, you're given the actual coordinate grid and the 2 points are located. For the second one, you're given only the coordinates. You need to find the distance between the 2 points for each problem. Alright, so for the first one, I'm just trying to find how far is it from one point to the other. How long is this line? Okay, well I can't use the blocks to count because it doesn't go straight across blocks, so I'm going to have to use something else. I'm going to use Pythagorean theorem. Okay, so I can count up, and that's 2, and over, and that's 3. Now, I could have also counted over and up, but as you can see, I still would have got 3 across and 2 up. So it doesn't really make a difference which way you count, as long as you make a right triangle. Okay, and since this is my right angle, that makes the line I'm looking for my hypotenuse, which is C. Well, that looks like the problems we just finished doing. I have A, I have B, I'm looking for C. So I can use Pythagorean theorem. A squared plus B squared equals C squared. So that gives me 4 plus 9 equals C squared. So C squared equals 13. If I take the square root of both sides, I get that C equals 3.6. So the distance between these 2 points is 3.6. And all I used was the Pythagorean theorem. Alright? Same thing for number 2. The only difference here is I'm going to find A and B slightly different. Okay? Instead of counting up and over, I'm just going to look and say, how far are these apart? So I'm going to look at my x's. And I say, okay, well I've got a 1 and a -3. How far apart are they? Well, they're 4 apart. Okay? If you need to look up at the number line, look at the +1 and the -3. How far apart are they? They're 4 apart. Alright? And then I look at the other two. I look at the 5 and the -1. I say, how far apart are they? Well, they're 6 apart. Okay? Well, this 4 and this 6 are my A and my B. Okay? If I drew the triangle out, the triangle sides would be 4 and 6 because that's how far apart these 2 points are. So now the second part of this is really the same. Whether I find my A and B by drawing a triangle, or whether I find my A and B by asking how far apart are they. Okay? Now, I could have subtracted. And done 1 minus -3, which would have given me the 4 that I already have. Or I could have done -3 minus 1, which would have given me -4. Well, it doesn't really matter if I used the 4 or the -4, because A being 4 gives me the same answer, because I'm going to square it. Okay, remember, we're talking about distance. So 4 and -4 both have the same distance. Okay, so either way, the answer is 4. And the same thing with 5 and -1. -1 minus 5 is -6. 5 minus -1 is +6. So either way, my B is 6. Okay, so now I just do the same thing I did on number 1. I use the Pythagorean theorem. So I have A squared plus B squared equals C squared. So that gives me 16 plus 36 equals C squared. So now I take the square root and I get C equals 7.2. So the distance between these 2 points is 7.2 units. Alright, now the last one. We're going to find the missing lengths again, except this time you only get one length and you have to find the other 2. Okay, now remember, you can only do this when you have a special right triangle. It doesn't work for all right triangles, just the 2 special ones. Alright, so you got 5 triangles. Okay, notice this one is 45 degrees, 45 degrees, and this side is 6 centimeters. This one's 60, that one's 30, and this side is 22 meters. This one's 30 and 60, and this side is 15 inches. 45 and 45 and 3 times the square root of 2 miles. And this one is 30 degrees and 60 degrees and 4 times the square root of 3 feet. So you need to find all 3 sides of all of these triangles. Alright, so let's look at number 1. First thing you should notice is that it is a 45, 45, 90 triangle. So since this side, this leg is 6, well, that lets me know that the other leg has to be 6 as well, because it's an isosceles triangle. this side is always the same as this side. Each leg on a 45, 45, 90 is equal. And then the hypotenuse is always the same number times the square root of 2. So that's all I had to do. No math. All you have to do is know your special triangle. If this is 6, then this is 6. And if this is 6, then this is 6 times the square root of 2. That's it. Now, that's the relationship for a 45, 45, 90. But this one is a 30, 60, 90. Well, I know the hypotenuse because it's across from the right angle. So this is the hypotenuse is 22 meters. Well, that tells me, because I know the hypotenuse is twice as long as the short leg, that the short leg must be 11 meters. Because the hypotenuse is twice as long. And then if the short leg is 11 meters, then that tells me that the long leg is 11 times the square root of 3 meters. Okay? Now, when you're doing a 30, 60, 90, always find the short leg first. Unless that's the one it gave you, and then you can find whichever one you want first. Okay? Because you use the short leg to find the hypotenuse. You use the short leg to find the long leg. Alright, so there's our relationship. Alright, number 3. Notice number 3 again is another 30, 60, 90. This time, we don't know the hypotenuse, we know the short leg. So I can find the hypotenuse. If the short leg is 15, then the hypotenuse is twice as long, so it's 30. And if the short leg is 15, then that means the long leg is 15 times the square root of 3. Okay? Notice the same relationship. This is 11, 11 square root of 3, 11 times 2. This is 15, 15 square root of 3, 15 times 2. Same relationship. Alright, number 4. This time, it's another 45, 45, 90, but this time I know the hypotenuse. Because the right angle is here, so this is the hypotenuse, 3 times the square root of 2. Well, that means that 3 is my number, so each leg is 3 miles. Okay, because 3, 3, 3 square root of 2. Just like this one was 6, 6, 6 square root of 2. Alright, now, number 5. Another 30, 60, 90. This time I know the long leg. Okay, so I need to find the short leg first. Well, if the long leg is 4 square root of 3, then that 4 is my short leg. The short leg is 4 feet long. And if my short leg is 4 feet, then my hypotenuse is twice as long, so it is 8 feet. Alright? Now, that is everything that you should know from Chapter 10. So hopefully this, along with your study guide, will be a good start in preparing for this test. Good luck.